Assalamu Alaikum everyone, this is me Abu Ahmed Chaudhary and welcome to AMI Chemistry class. Today we are going to learn more about neutralization and also we are going to have a short review on the previous things that we have learned in this chapter. So let's not talk too much and let's get to the work. Thank you. So guys, as you guys are seeing here that I have written the definition which I have written in the previous class, that what is a neutralization or what is neutralization reaction. This question may come in two different ways. That first one is that what is neutralization, or the second one is that what is neutralization reaction. Both are the same thing. As you guys know that both are the same thing. So what is neutralization reaction or what is neutralization? Neutralization reaction is a reaction of an acid and a base that results in an ionic compound and possibly water. A neutralization reaction is a reaction of an acid and a base that results in an ionic compound and possibly water. So for example here I have given that hydrochloric acid plus sodium hydroxide. Here hydrochloric is an acid. Hydrochloric is an acid. AQ, the form of hydrochloric is aqueous. Aqueous means that the water is present in there. Water is present in there in the acid, and so in the base sodium hydroxide NaOH, sodium hydroxide, it is also in aqueous form, as there is no pure, as the pure form of acid is very tough to make and it's very expensive to find, and also the base, the pure form of base, it may be difficult to find or something like that, but usually we use the aqueous form. So hydrochloric acid plus sodium hydroxide solution, hydrochloric acid plus sodium hydroxide solution, when we mix together or when we react them to, and when they react together, they form sodium chloride salt. Sodium chloride salt, which is the table salt, and it should be in the aqueous form, which means that the salt will be not in the solid form, water will be present in that, and H2O liquid and H2O liquid. H2O liquid means that the water cannot be aqueous. Water is itself an element, is a combination of two elements, which is a water. It has a H2O is a molecule. H2O is a molecule, and this molecule is present everywhere. For example, in hydrochloric acid, water is also present. In sodium hydroxide, water is also present. In sodium chloride, there is also water present, and in water, water is present. So water is liquid. Now let's come to the point that during a neutralization reaction, the H plus ions of the acid are turned into water. During a neutralization reaction, the H plus ions of the acid are turned into water. Full stop. Please take the essence of this thing and please write the things which I am saying right now. A neutralization reaction is also an exothermic reaction. It gives out heat. So the temperature of the solution rises a little. So we can also say that the neutralization reaction, or another name for neutralization reaction, is also an exothermic reaction. Why? The reason for calling the neutralization reaction an exothermic reaction, because it gives out heat when the solution or when the thing is produced. For example, sodium chloride and H2O liquid are produced. So the temperature rises up, the temperature of the solution rises. That's why it is, as it is releasing heat to the surroundings, so it is an exothermic reaction. Let me write the point for you. So you guys are seeing here that a neutralization reaction is also an exothermic reaction. A neutralization reaction is also, sorry, there should be another word, that node. Or you can also write this thing, that a neutralization reaction is also an exothermic reaction. the temperature of the solution rises because the temperature of the solution, so the temperature of the solution rises a little bit. Let me do a little bit of correction here. So I have done some correction here that the neutralization reaction is also an exothermic reaction, comma. The neutralization reaction is also an exothermic reaction, comma. So the temperature of the solution rises a little bit. So the temperature of the solution rises a little bit, full stop. Now, I have written the meaning of exothermic reaction for those people who don't know or who forgot what is the meaning of exothermic reaction. Exothermic reaction is basically the reaction. Exothermic reaction is basically the reaction which gives out heat to the surroundings. For example, when you are boiling water, water at first it's endothermic reaction as it is absorbing heat, and later on it is releasing. When the water is boiling, when you are going to put your hand above, you are going to feel a little amount of heat. Or when you are going to hold that kettle or the pot in which you are boiling the water, you will feel heat because the heat is releasing by the pot. The heat is releasing to the surroundings by the pot. Now let's come to the endothermic reaction right now. As I am explaining the exothermic reaction, let me explain the endothermic reaction also. Now endothermic reaction is basically just the opposite. Endothermic reaction takes in the heat from the surroundings. For example, ice. The best example for endothermic reaction is that ice to water. And another example of exothermic reaction is water to ice. For example, you are putting normal water, you are putting room temperature water into the freezer, and after a period of time the water has been freezed and it has become ice. So the thing here the reaction that occurred here is that the normal room temperature water has still a little amount of heat, and it is releasing the heat, and as it is releasing the heat, the inside is become cool. So as it's becoming cool, it is solidifying, and the solid form of water is known as ice. And the opposite thing happens when you put an ice cube on the table. For example, you put an ice cube on a plate and you put the plate on the table. After 1 to 2 minutes, you are going to see that the ice is melting. After taking out immediately, you will see that the ice is melting. It's because the ice is taking heat from the surroundings. There is an absence of heat in the ice, so it is absorbing heat, and there is a presence of heat in the normal room temperature water. That is why it is releasing heat. So one is exothermic reaction, another one is endothermic reaction. So that was not our chapter here, but still I explained you guys for those who didn't know what is an exothermic or endothermic reaction is. Now we could obtain solid sodium chloride. Please write this line, that we could obtain solid sodium chloride by heating the last solution above. The water evaporates, leaving the solid NaCl behind. For example, now as we have got the solution it's a salty water, right? It's a salty water. Now we are going to heat that salty water, and after a certain period of time we are going to see some white solids. Left at the bottom of the beaker, and that is our salt. The thing that occurred here is that as we are heating the water, we know that water exactly melts at 100 or boils at 100 degrees Celsius and melts at 0 degrees Celsius. So the water is gonna boil at exactly 100 degrees Celsius, and for sodium chloride it needs a very high temperature than water to melt. It needs a very high temperature than water to melt. So we are gonna see some solid sodium chloride left at the bottom of the beaker. Let me show you the diagram here. Then you can understand. So as you guys are seeing that I have drawn a beaker which is containing salty water, and we are heating that salty water using a stove. So we have lighted a stove and we have put a steel gauge on the fire, and then we have put the beaker. We are directly not putting the beaker on the fire because we have to hold that, and for that reason the beaker will be hot very soon. The beaker will become hot very soon, although it will become hot right now also, but here we don't have to hold it. Here we don't have to hold it. Otherwise we would see that there would be some cracks. There would be some cracks on the beaker. Here the thing that is going first here, that after we have lighted the stove, the fire is heating the steel gauge. At the very beginning, the fire is heating the steel gauge, and then it is heating the salty water. Then, now imagine, after a certain period of time, this salty water the water from the salty water solution will disappear. Let me draw the second diagram. See, here the water is actually becoming low from where it was. For example, if the solution was 100 cm cube, if the solution was 100 cm cube, now it is suppose it's 25 cm cube. After a certain period of time, now it's 25 cm cube, and we are seeing that the water is being evaporated from the salty water solution. The water is being evaporated, and later on we are going to see that some salts are going to remain on, some solid stuffs are going to remain on the bottom of the beaker, and that is going to be our sodium chloride solid, but still it will be hydrous sodium chloride. Hydrous sodium chloride means that still it is insolid, but still it contains water. যেরকম ফর এক্সাম্পল, যেরকম আমি বলি যে আমরা অনেক সময় দেখব যে বর্ষাকালে লবণ ভিজে যায়, একটু ভেজা একদম পুরো পানি হওয়ার আগে লবণ কিন্তু প্রথমে একদম সাধারণ লবণের মতনই থাকে। সাধারণ প্যাকেটে যেরকম লবণ থাকে সেরকম প্যাকেট থেকে খোলার পরে সেরকম থাকে বর্ষাকালে। কিন্তু কিছুক্ষণ পরে এটা যদি খোলা রেখে দেওয়া হয়, কিছুক্ষণ পরে দেখবো যে ওইটা একটু আস্তে আস্তে ভিজা হয়ে যাচ্ছে, লবণটা আস্তে আস্তে ভিজা হয়ে যাচ্ছে। স্টিল ইট ইজ নট কমপ্লিটলি এ সলিউশন, বাট ইট ইজ বিকামিং লিকুইড. Slowly it's becoming liquid, which means that because of the temperature outside, because of the humidity outside, there is a water present in the humidity, so the salt is absorbing that water. The salt is absorbing that water, and later on we are going to see that the salt is little bit in a liquid form, but not totally liquid. It's wet. The salt is wet. We are going to see wet salt. That's hydrous salt. Hydrous salt means that the salt is in solid form, but still it has water in it. Let us revise this thing very quickly right now. Now we could obtain salt, as I have said, formula হচ্ছে acid plus base is equal to salt plus water, or acid plus alkali is equal to salt plus water. In the previous chapter, we have learned that acid plus alkali also gives us a salt and water reaction. For example, hydrochloric acid is a hydrochloric HCl is an acid, and sodium hydroxide NaOH is a base, and also an alcohol is also an alkali. So when an acid and an alkali, or when an acid and a base reacts, there it forms salt and water. For this class, for your age, you're just gonna need to know that acid plus base and acid plus alkali gives us the same thing. But when you're gonna get in IGCSE, you're gonna learn the difference between an acid and a base. You can say that all alkalis are a base, but not all. Sorry, all bases are an alkali, but not all alkalis are base. All bases are alkali, but not all alkalis are base. I have shown the formula in the last class, so I'm not going to show it right now. Now let us see that how many types of neutralization reactions are there. There are 4 types of neutralization reaction: strong acid and strong base, strong acid and weak base, weak acid and strong base, strong acid and strong base, strong acid and weak base, weak acid and strong base, weak acid and weak base. Let me write these 4 types of neutralization reactions. So as you guys are seeing here, that I have written the types of 4 types of neutralization reactions: strong acid and strong base, strong acid and weak base, weak acid and strong base, weak acid and weak base. I'm giving you a certain period of time. After a few seconds, I'm gonna erase this thing, and I have to write something else, or I have to explain you something else. Please take a essay of this thing, or please pause the video and write it on your note copy. Now I'll erase this thing. As you guys are saying that I have written something on the board, and this thing is that why neutralization is important in daily life. For example, neutralization may be not important for you. You may not understand the importance for neutralization in your daily life, but those who continuously work with chemicals and other things, for example, chemical engineers or something like that, or scientists who discover something or need to do something with the chemicals, so they know the importance of neutralization. Neutralization reactions are important in everyday life as they are responsible for the pH of a solution. Neutralization, neutralization neutralization reactions are important in everyday life as they are responsible for the pH of a solution. Neutralization reactions are important for everyday life as they are responsible for the pH of a solution. The pH of a solution is important. The pH of a solution is important because it determines how acidic or basic the solution is. For example, there are 2 types of solutions. One is acidic solution and another one is base solution, which means that one is acid, another one is alkali. So there are 2 types of solution, right? There are 2 types of solution. One is acidic, another one is basic. So the pH value shows that how acidic or basic the solution is. How acidic or the basic solution is. It is important because it affects how the solution behaves and how it interacts with other substances. It is important because it reacts. It is important because it shows how the solution behaves and how it interacts with other substances. For example, it is you. Your manners are important in human life because your children or we represent, or a person represent his or her individual family. If his or her behavior is not good or manner is not good, what we are going to consider? We are going to consider that his or her parents didn't teach them anything. We usually think like that, but no parents teach their children to behave badly with others. I know there may be. You may say that there are maybe some parents who behave badly with others, so children are learning from them. That's a different thing. That's a totally different thing. And let's come to the point here that it is important because it affects how the solution behaves and how it interacts to or with other substances. Now come to the point that factors that affect the neutralization reaction. First of all, the concentration of acid. For example, and for an equal amount, for an
acid, for 50 cm cube of acid, you cannot take 1 cm cube of alkali or 1 cm cube of any base, and vice versa. For 50 cm cube of a base of an alkali, you cannot take 1 cm cube of an acid. So you have to take the appropriate amount. So this is the concentration of the acid. The concentration of the acid. Now the strength of the acid. By the strength of the acid, I mean that for a strong acid, you can take strong base or a weak base. For a strong acid, you can take a strong base and a weak base. For a weak acid, you can take a strong base and a weak base. Okay, you cannot take that strong acid, strong acid, strong base, strong acid, weak base, weak acid, strong base, weak acid, weak base. These are the strength types. That you have to measure the strength. That by measuring the pH value, we can measure the strength of the acid, which means that the pH value shows that how acidic or basic the solution is. If the acid is too much acidic, we need to prepare our things like that. We have to prepare our things like that. That is the strength of the acid, and same goes with the strength of the alkalis. The strength of the alkalis, and also the one major thing is that the temperature. When you are going to rise the temperature of something, the thing or the reaction occurs very fast. The reaction occurs very fast. And whenever you are going to cool down the reaction, when you are going to cool down the temperature of the surrounding, the reaction becomes slow. For example, if you want to do something, for example, if you want to make tea, you need to give some heat, right? Now, if you are giving a minimum amount of heat, which is below the activation energy, or which is below the energy which is needed to boil the water, which is exactly 100 degrees Celsius amount of energy is not being provided. If 2 degrees Celsius or 5 degrees Celsius of heat is produced, heat is generated, or heat is being transferred to the beaker or the pot you are making tea, the pot will not get hot immediately, or it won't get hot very soon. It will take its time. But if you increase the temperature, then the reaction is going to be faster, which means the water is going to be boiled quickly, which means that the temperature 100 degrees Celsius that is needed to boil the water is going to reach very soon. Otherwise, it's going to take too much time. That's the fact. Now let's come to a new point, that in acid or basic solution, these few were also knew that why neutralization is important, and also the 4 factors of neutralization. We didn't learn this in the previous class. So now we are going to learn that in an acid or basic solution, the concentration expresses how much acid or base is dissolved there. Yes, the same thing I just said. To neutralize acids, you need equal amounts of base and vice versa, and therefore more concentrated solution require more of reagent, which means that acid is a reagent for basic solution for alkali. For example, you cannot neutralize without an acid and alkali. These two are supplements of each other. These two are supplements of each other, and these two are incomplete without each other. For example, you cannot get sodium chloride solution if you don't react sodium chloride, if you don't react HCl, if you don't react HCl and sodium hydroxide together, you cannot get sodium chloride and water. So these two are supplements of each other, for which you cannot complete the reaction with another. They depend on each other. That is why it is called the reagent. Acid is the reagent of alkali, and alkali is the reagent of acid. Now, alkali is dissolved in water to give alkaline solutions. Alkali dissolves in water to give alkaline solution. All these react in a similar way too. So they must have something in common. Alkaline solution contains hydroxide ions. See, alkaline solutions contains hydroxide ions. See, sodium hydroxide. Sodium hydroxide has Na plus ion and OH minus ions. NH3 plus H2O. NH3 plus H2O. NH3 is a ammonia gas. NH3 is ammonia gas, and we are gonna react water with ammonia gas. What we are gonna get? We are gonna get ammonium NH4 plus aqueous, ammonium in liquid, ammonium in aqueous state, and also OH negative ions, which means that it is an alkaline solution. Several problems in life are caused by too much acidity. Or too little. They can be solved by neutralization reactions. That's all for neutralization, and in the next video first I'm going to write some parts and then we are going to start a new chapter, inshallah. So Assalamu Alaikum everyone, and thank you for staying with Ami.